Hey friends, my name is C and you're watching MakesItEasy, and welcome to a new video for IGCSE Maths. And today we have questions for trigonometric functions or equations. And these videos are from DFM or DrFrostMaths, so if you want to check it out, you can check out the description for the PDF. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And let's get right into the first question. Express this right here, this expression, as a single trigonometric ratio. So we first have to identify how we could simplify this. So what I can do is I can first factorize the sine theta from the top, from the numerator. So it'll be sine theta 1 minus sine squared theta all over cos to the power 3 theta, like cos cubed theta. And we know that from last lesson, the rules and examples, the video last lesson, we have the Pythagoras Identity, where sine squared theta or x plus cosine square, cos square theta or cos square x equals 1. And if you rearrange it, you get cos square theta equals 1 minus sine square theta, which is what we have here. So this one right here is basically cos square theta. So let's put it right here. So it'll be sine theta cos squared theta over cos cubed theta. So we can cancel the cos squared theta and 2 of the cos cubed theta to end up with sine theta over cos theta. And if you simplify it, it's one of the identity, which is equal to tan theta. So tan theta, and that's the answer. Number 2. Express 1 minus tan theta sin theta cos theta in terms of cos theta. So you first have to expand this right here. So just ignore this part first, ignore this part. So tan theta is sin theta over cos theta. You have to multiply by sin theta and multiply by cos theta. So from here we can see that the cos theta cancel out, so it'll be sin square theta. Adding the 1 minus, it'll be 1 minus sine squared theta, which from just now we saw that it's one of the Pythagoras identity, which is equal to cos square theta. So that's the answer. So the answer is cos square theta. Then question number 3. Prove that tan square x minus 1 is equal to 1 minus 2 cos square x over cos square x. So this right here, this 3 lines is basically the same as equal. But this is like, it always holds true, like an identity. Like let's say a square minus b square is always equal to a plus b, a minus b, because it will always be this way, it's an identity. So what we can do is that we can first, let's just ignore the right side, because we have to prove that. So we'll focus on the left side. Tan square x can be written as sine square x over cos square x minus 1, and combine the two together to get sine square x minus cos square x all over cos square x, like so. And what I can do is I can change this sine square x to something over like something minus cos square x, which from just now it was one of the Pythagoras identities. So it'll be 1 minus cos square x minus cos square x over cos square x. And then you can simplify the numerator. So 1 minus cos square x times by 2. So it will be 1 minus 2 cos square x over 1 minus 2 cos square x over 2 cos square x. And that's how we prove it. QED to show what needs to be shown has been shown. So that's it. And you can just put it here. In question 4, prove that tan theta plus 1 over tan theta is the same as 1 over sin theta cos theta. So we can first rewrite this. So it'll be sin theta over cos theta plus, because 1 over tan theta means that the tan theta in the bottom can be inverse. So it's the same as sin theta over cos theta plus cos theta over sin theta, like so. And we can just expand, like combine those two together you get sine square theta plus cos square theta by like cross multiplying over sine theta cos theta. And remember the Pythagoras identity where sine square theta plus cos square theta is equal to 1. So therefore the top will be 1. Oops, and this shouldn't be a times. It should just be, sorry, it shouldn't be a plus, it should just be a times. Times by cos, like so. And then the bottom will just be sine theta cos theta, which is what we need to prove. Sine theta cos theta. And that's the answer. QED. And question 5. Prove that 2tan theta plus 1 is the same as 1 plus the sine square theta over 1 minus sine square theta. So we can first look at the left hand side. We can turn it into sine and cos in terms of them. So rewriting it, you will get 2 sine square theta over cos square theta plus 1. And you can basically combine the two together to get 2 sine square theta plus cos square theta over cos square theta, like so. And you can combine this, you can turn this cos square theta into identity that we saw just now, as well as the one in the bottom. So it will be 2 sine square theta plus 1 minus sine square theta over 1 minus sine square theta. And what you do is that you basically just simplify this and evaluate it. So basically just simplify, and then it will just be 1 plus sine square theta over 1 minus sine square theta. And that's the answer. QED. Oops, QED. Then question 6. Work out PQ giving an answer in the simplest form. And P and Q are matrices. So to multiply matrices, you basically just have, the answer will be like this in terms of this, right? There will be value here, value, value, and value. So the first value here, you get by multiplying this by this. And this value right here, you get by multiplying this by this. And the third value in the bottom right, you get by timesing this by this. And the fourth value here, it'll be this times by this. So let's just work that out. So the first value will be sine x times sine x plus cos x times cos x. So it'll be sine square x plus cos square x, like so. And the second value will be sine x times minus cos x. So minus cos x sine x. And then it'll plus cos x times by sine x. Sine x cos x is the same. Cos x. Then the third value will be minus cos x times by sine x plus sine x times by minus cos sine x times by cos x. So it'll be minus cos x sine x plus sine x cos x. Sorry, it's a bit messy. And then the fourth value will be minus cos x times minus cos x plus sine x times sine x. Will be sine x squared plus cos x squared. And simplifying it will get us like this, 1, 0, 0, 1. Because this is in Pythagoras identity, which is 1. And these two cancel out, and this is the same as 1. Then we have question 7. Angle theta is obtuse and sine theta equals root 11 over 6. Work out the value of cos theta. So we know obtuse angle means it's more than 90 degree but less than 180 degree. So if you look at the cast diagram, it will land between here because it's more than 90 degree but less than 180. And using the cast, it will be add sugar to coffee. So this quadrant, which is the second quadrant, will only have sine as positive. That means cos and tan are negative. So let's just draw out this triangle right here. Theta. So theta is so, right? Sine equals opposite over hypotenuse. So hypotenuse is 6. Opposite is root 11. And we have to find this unknown right here, which you can use to use Pythagoras theorem. 6 squared minus root 11 squared. And take the square root of the answer, which is 5. equals 5. So you just do cos theta equals basically C equals A over H, so katoa. So the A is 5 and the H is 6. And don't forget to put a negative because it's in the second quadrant. So cos theta equals minus 5 over 6, like so. In question 8, the value of sine 73 degrees is equal to 0.956 to 3 significant figures. Use a sketch to find two angles between 0 to 360 degrees for which sine x equals minus 0.956. So we can basically split this into two. It'll be y equals sine x, and y equals 0.956. So to find the value of sine x where it's equal to y, like the y value is equal to minus 0.956. So we can draw a straight line at y equals 0.956. We just wrap it around here, right here. It's not really accurate because I don't have the grid, but basically these two are the solutions. And basically just look them from the side, just compare them. If you draw a straight line up, it's not that straight, but you get the idea. So these two will be the answers, which if you calculate correctly, it will be x equals 252 degrees and x equals 287 degrees. Like so. In question 9, 2 sine theta equals minus 1.36 for 0 like this. Find like theta, solve. So we can divide both sides by 2 first. So sine theta equals minus 1.36 divided by 2 will be equal to minus 0.68. And remember from last lesson, when we have a negative trigonometric equation, we can't just do sine inverse and get the answer. We will first get a base answer. So like the theta base answer, it will be sine inverse 0.66. You take the positive number, which will be, let's see, sine inverse 0.68. Sine inverse 0.68. You get a degree of 42.8 degrees. And that's not the final answer, that's the base answer. To get the first answer, you will do, let's put it on top here. The first answer will be equal to 180 plus by the base answer, 180 plus the base. And the second answer will be 360 degrees minus the base answer. So 180 plus the base answer will get you 222.8. So 222.8. And the second answer with 360 degrees minus the base answer will get you 317.2. And these two are the answers. Then question 10. Solve the equation cos square x equals 0.8 and give your answers in one decimal place. So we first have to square root both sides to get cos x equals the square root of 0.8 is, let's see, 2 root 5 over 5. So 2 root 5 over 5. But don't forget, when you square root a number, it will be plus and minus. Because if you square root a minus, it will be a plus. So there will be two answers here. It will be cos x equals 2 root 5 over 5. And cos x equals minus 2 root 5 over 5. So the first one will be much more simpler, because it will be cos x equals cos inverse 2 root 5 root 5, which will give you an answer of cos inverse 2 root 5 root 5, 26.6 degrees. And the second answer will come from doing 360 degrees minus the first answer, which is 333.4 degrees. 333.4 degrees. And these are the first two answers. And for the negative, you have to get a base answer of x base equals, let's just see, cos inverse 2 root 5 root 5, which will be this answer right here, 26.1. So 26.6 degrees. So to get the two answers from a negative trigonometric equation, you do the first answer will be 180 degrees plus the base, and 180 degrees And the second answer is 180 degree minus the base. So let's just work out the first one. It'll be 180 plus by 26.6, which is 206.6. So let's put it here, 206.6. And the second answer, which is just 180 degree minus the base, which is 153.4 degree. And let's put the rest of the answers to get this. Like so. And question 11, solve 2 sine x minus 3 cos x for 0 to x to 360 degree. So we first have to rearrange the equation to get everything to one side. So it would be 2 sine x plus 3 cos x equals 0. And we can divide everything by cos x to get tan. So it would be 2 tan x plus 3 equals 0. Get tan the subject to get tan x equals minus 3 over 2. And then you just do tan inverse to both sides. So this x, the base answer will be tan inverse 3 over 2, which gets us tan inverse 3 over 2, which is 56.3 degree. So remember for tan, the first answer will be 180 degree minus the base. And the second answer is a bit different. It will be the first answer plus 180 degree. So the first answer will come from 180 degree minus 56.3 degree, which is 123.7 degree. And the second value will be 123.7 plus 180, which is 303.7 degree. And these are the answers. Then we have question 12, solve 5 sine square x minus 2 sine x equals 0. So we can factorize sine x out of everything. So it will be sine x, in brackets 5 sine x minus 2 equals 0. So we have two solutions here, two equations. So it will be sine x equals 0 and 5 sine x minus 2 equals 0, which is just sine x equals 2 over 5. So we can solve this first. The first answer will be x equals sine inverse of 0. With sine inverse of 0, you will get, I'm pretty sure it's 0. Yes, 0. And then you have to plus 180 minus 0 to get 180. And then the third answer, you have to do 0 degree plus 360 degree because it's a whole full circle around. Like so the first three answers will be this. And the two last answers will be from here. X equals sine inverse 2 over 5. That will get us sine inverse 2 over 5, which is 23.6 degree. And then the second answer will be 180 degree minus the first answer, which is 156.4 degree. Like so. And these are the two answers. And basically just put them back to the answer format. So the first one will be 0 degree. And then it will be 23.6. Then 156.4. 180 degree. And 360 degree. Like so. And question 13, solve this right here. So like just now, you have to factorize the tan theta, and then tan theta plus 3 equals 0. So rearrange the equation to get two equations, which is tan theta equals 0 and tan theta equals minus 3. So let's solve the first one first. So tan theta equals 0. Theta will be equal to tan inverse 0, which is tan inverse 0, which is 0 degree. And the second answer you do by adding 0 by 180 degree, which is 180 degree, and add a full circle around 360 degree. Like so. And for the second solution, you'll first get a base answer, which is theta base is equal to tan inverse 3, and that will get you tan inverse 3, 71.6. So the first answer the first answer will be 180 minus the base answer 71.6, and the second answer will be the first answer plus by 180 degree, and this works out to be 180 degree minus 71.6. It will be 108 degree, and then the second one will be 108 degree plus 180 degree, which is 288 degree. So these are the 5 solutions. So x equals, there are a lot, so I'll just write it out. 0 degree, 108 degree, 180 degree, 108 degree, 288 degree, and 360 degree, like so. And moving on to the last question, it says it can be shown that 2s plus 1 times by s minus 1 equals 2s squared minus s minus 1. Hence or otherwise solve this right here. So it basically gave you the answer already, because you can see that this format right here is the same as this format. That means it can be factorized in this way. In this case, sine theta is equal to s, right? So you can just put it this way. So it will be equal to 2 sine theta plus 1 times by sine theta minus 1 equals 0. That means you have 2 answers. It will be sine, the first one, and second one. Sine theta equals minus 1 over 2, and sine theta equals 1. Like so. So for this one, you get a first of a base answer of theta. It will be sine inverse a half, which will get you sine inverse a half 30 degree. So 30 degree. So remember, to get the first answer for theta for sine, you do 180 plus the the base answer, and the second answer, which is theta 2, will be 360 degree minus the base answer, which we'll leave it for now first. But for this one, it will be theta. This is right in new color. Theta equals sine inverse 1, which can get you sine inverse 1. Sine inverse 1 will be 90 degree. And then the second solution will be 180 degree minus 90 degree, which is just the same 90 degree. So we don't have to write anything. So the answers is, so theta 1 will be 180 degree plus 30 degree. So it will be 210 degree. And then the theta 2 will be 360 degree minus 30 degree, which is 230 degree. And the first solution will be 90 degree from here. And those are the final answers. And that's it for this questions video for trigonometric ratios or equations or any functions. And I hope you find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive feedback about my channel or my YouTube or my website or anything, you can drop them off in the comment section and I'll reply to them. And check out my social medias for more information or for more content, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be rules and examples for differentiation, which will be an interesting topic. But until then, stay safe and happy learning.